And this is a hints video for group activity 15, exponential models, on page 149 and 150. Our first example asks us to look at a cup of coffee in a covered mug. The initial temperature is 180 degrees Fahrenheit, and it cools down exponentially by 1% per minute. So that's the rate, 0.01, if you divide by 100%. Determine the exponential model equation. So in this case, y equals the initial times 1, and it's cooling down, so it's taking away 0.01 as the rate, and it's raised. So I'm going to insert equation here. Design, we would need the superscript. So this is raised to the x, which is the number of minutes after the mug is covered. So then we just need to simplify that by actually multiplying. So y equals 180 times 0.99 remaining raised to the x. I'm just going to copy and paste this. Okay, so that's our model. And you can use that to predict the temperature after 6 minutes. X equals 6, the number of minutes after the coffee is poured, I guess. And label your answer, so use proper units. Now we're going to use Excel to determine the temperature of the coffee after 6 minutes. So just a blank Excel sheet here. I'm going to start at, or let me label this first, minutes. I'll start at 0, and I'm going to start using a series here. So I want to fill a series, and this is the column A, right? It's going to be linear, meaning it's going to increase at the same value, which value will be 1, and I want this to stop at 6 minutes. Okay, so it fills it in for me, and I'm just going to center these, it looks nicer. Then this is going to be the temperature of the coffee. And so remember, this is a formula. It's going to be 180 times 0.99 raised to the number of minutes. So that's going to be, well, I want it to be A2. And so I should probably say over here in degrees Fahrenheit. And I'm going to fill this formula down just by going to the bottom right corner and double clicking that. I'm getting all kinds of decimals here, so what do we want this decimal place to be? It doesn't say, so let's just go with 2 decimal places here. So that they're all the same. Okay, so those are our temperatures. And after 6 minutes, this should be the answer that you got when you calculated that for number 2 there. And then we're just going to copy and paste that value in here. I'm going to copy and paste both of these. And I always paste these as a picture or text only, because if you keep the formatting, it may mess up depending on your Excel chart. So just picture or text is fine. Then we want to predict when it's going to be 100 degrees for the temperature. You can see that that's going to happen sometime, but so let me come in here and mess with my series. I don't want it to stop at 6 anymore. Let's go. I know I'm going to need 2.5 hours. So how many minutes is that? That's 120 plus 30, so 150. Oh, shoot. Undo. because I want that to go down, not right. So column. Let's go 250. And then I'm just going to come here and double click this to fill that down to the rest of them. So we can use that to see where we get to 100 degrees, and that is between 58 and 59 minutes there. Then see what happens after 2.5 hours. So 2.5 hours, 2 hours is 2 times 60. So that's 120. So it's actually 150. That's going to be 2.5 hours there. It's pretty cool that we can see. Do you think it's really going to get down to this temperature though? Probably not, because eventually it's going to hit room temperature and just kind of sit there. So it's not completely accurate after a point. It's just a model. Actually, that answers number 6, doesn't it? Then number 7, we're talking about something different here, the cave paintings, and 14%. So it gives us a rate of decay here for every 100 years. So I'm going to start a new Excel file for that, because this is actually going time, or years actually. And what's the other variable? Carbon 14 remaining. So remaining carbon 14. All right, so we start at 0, and this actually goes every 100 years. So I'm going to fill this